All right, question 4 on the math subject GRE practice test. This is test 3768. So the topic for this problem is what's called implicit differentiation. Typically something taught near the middle or the end of a Calc 1 class. Differentiation because we're trying to find the derivative here, the derivative of y with respect to x. Implicit because in the more standard case you're given a function and told to find, I don't know, f prime of x or something. But sometimes the y variable is not solved for. We don't know what y or f of x is equal to explicitly. Instead, it's given implicitly by this equation. So implicit because you got an equation, differentiation because we're looking for the derivative. They don't have to ask you dy over dx, but that's kind of the standard use of the variables. The letter you see up in the numerator, y in this case, is telling you to treat the y's like they're a function, and the letter in the denominator, the x, is just telling you that x is the variable. So the idea with implicit differentiation is you're just going to take the derivative of both sides of this equation. So the derivative of x, as you're probably pretty familiar with, is just equal to 1. The derivative of y to the 4th power, be a little careful here. You might think it's 4y cubed, but it's not 4y cubed because y is not the variable. Y is a function. So even though it doesn't look like it here, you really have a chain rule going on. So when you see y to the 4th power, sort of think about y as representing a function. So whatever function you want, it doesn't matter. Sine of x maybe, sure. Think about sine of x to the 4th power. In this specific example, y is not equal to sine of x, but maybe this will help you remember what's going on. If you were taking the derivative of this, you'd have to use the chain rule. You take the derivative of the outside part. So using the power rule, the 4 goes down in front and this changes into a 3. Then you leave the inside part completely alone. You'd leave this as sine of x. But then you wouldn't be done because you'd still have to take the derivative of sine of x. So you'd multiply this by the derivative of sine of x, which is cosine of x. It's the same idea down here. We've taken the derivative of the outer part with this 4 and this 3. We leave the y completely alone, but then we're not done. We have to multiply this by the derivative of y. What is the derivative of y? Well, it's exactly this, dy divided by dx, or sometimes it's written as y prime. We're now done differentiating the left side of the equation. Differentiating the right side is pretty easy. 10 is a constant. The derivative of a constant is just equal to 0. Take the derivative of both sides of the equation you get here. You won't see this equation as one of the answers because that's not what they're asking for. They're asking for the derivative of y with respect to x, aka y prime. So you need to solve this equation for y prime. I don't know, maybe subtract 1 from both sides of the equation, then divide both sides of the equation by 4y cubed. You get y prime, aka dy over dx, is equal to negative 1 divided by 4y cubed. Come up to your answers. Hope you see that somewhere. Yep, you do. It looks like that's answer A. This would be the standard way to solve this using this method called implicit differentiation. However, it's worth pointing out that you don't need to solve the equation that way. It's just the most straightforward. What you'll see is you can get the same answer if we differentiate a little bit more explicitly. If we solve this equation for y, maybe subtract x from both sides of the equation, we get y to the 4th power is equal to 10 minus x. Then take the 4th root of both sides of the equation. Y is equal to, maybe I'll write that as 10 minus x to the 1/4 power. Now we've solved for y explicitly, so when we take the derivative, we don't need implicit differentiation. If y is equal to 10 minus x to the 1/4 power, y prime is equal to 1/4 times 10 minus x to the, 1/4 minus 1 is negative 3/4. But then you're not done. You still have to multiply by the derivative of the inside function. The derivative of 10 minus x is 0 minus 1, aka negative 1. You can clean things up a little bit here and say that y prime is equal to negative 1 divided by 4 times 10 minus x to the positive 3/4 power. And you're like, wait a minute, you got a different answer over here than you got over here. No, I didn't. This answer is just written in terms of y, whereas this answer is written in terms of x. This equation relates together x's and y's, so we can use this equation, or maybe a more useful form of that equation, to substitute back in to get this answer written in terms of y's. Recognize that 10 minus x to the 3/4 power is the same as 10 minus x to the 1/4 power raised to the 3rd power. Because when you have exponents raised up to exponents, you multiply them together, and 1/4 times 3 is 3/4. Now maybe notice that inside this outer set of parentheses, I got 10 minus x to the 1/4 power, which up here we wrote is exactly what y is equal to. So I can change that into a y, and voila, I get the exact answer that I came up with over here. There's really no reason to solve this problem this way. It's more steps, it took a little bit more time. And most importantly, it's not as powerful because this method only works if you can solve this equation for y. But maybe you can imagine a different equation, maybe that had multiple y's in it or something, that was really difficult to solve for y. If it's really challenging to explicitly express y in terms of x, then you're going to have a really hard time getting to this step, and you wouldn't want to do the problem this way. I just thought it might be useful to show that there's multiple ways to solve it and get a little bit of review with algebra as I go through here.